Gregor Mendel was a man with an extraordinary power, his own curiosity and determination. One day this brilliant man said,
"Let's just breed some pea plants, I guess."
and he did, but he didn't just breed pea plants. He decided to breed the greenest of pea plants with those that were a blistering yellow, just to see what would happen. To Mendel's utmost surprise,
They're all green. Ugh. You know what I think? The yellow trait is recessive because it disappeared and left it alone.
but this did not satisfy Gregor Mendel.
Why did the recessive trait disappear? I must conduct more experiments to find this out.
And that's exactly what Mendel did. This time he took pea plants that were short and pea plants that were tall. This time less surprising,
Wow, these peas are higher than the sky itself. Guess the rest of the recessive trait just disappeared, huh?
then, suddenly, Mendel had a stroke of genius.
I don't think that's enough. I'm gonna breed some of these plants. Let's see what happens.
Mendel cross-pollinated the F1 generation in each group of pea plants just to see what would happen. First, he tried this with the green and yellow pea plants. Then with the short and tall pea plants. And, as history goes, this is where it gets wild.
What incarnation is this? Most of them are like the dominant big and green ones, but some of them came back yellow and short. I guess I don't know what happened.
It was true. In the color group, about 75% of the pea plants had the dominant trait of being green, while 25% had the recessive trait of being yellow. It was the same ratio for short and tall pea plants, where 75% were tall and 25% were short. How did this happen, you may ask? Let's use short and tall pea plants as an example. Each trait has its own allele, or factor as Mendel called them. The allele for tall pea plants is dominant, so we'll assign it a capital D. The allele for short pea plants is recessive, so we'll assign it a lowercase d. Now, look at the Punnett square. In Mendel's first experiment, he bred pure tall pea plants with short pea plants. As you can see, each pea plant now has one dominant allele, which masks its one recessive allele. This results in every pea plant being tall. In his second experiment, Mendel bred the offspring of the parents, or the F1 generation. 75% of the pea plants were tall, but 25% were short. If you look at the Punnett square, you can see that this is due to only one spot having the two recessive alleles it needs to be short. This was what led to Mendel's principle of segregation, which states that for any particular trait, the alleles, or factors, from each parent separate, and only one is passed from the parent to its offspring.
Yeah, do it, come on. Okay, that's good.